Okay, hello everyone. I hope you can hear me. Okay.
Last month and actually the first question that last week was go through.
Let's start.
Having time to go through.
So the question says, Abu, Abu and Hasung, you can hear us, right? Okay. Thank you. Okay. The question says that if you have a p-value of 600 Newton, and let's say our 600 Newton is acting here, and this distance is 0.8 meter. Uh, 0.8 meter, and this is P. The question says that if this is 50 kilograms, and this is 1 meter by 1 meter, so you have to determine the AG when the object has not tipped. Okay. So the first thing all of you will tell me is this a rigid body kinetics problem or not? Let me see how many names I think I forgot your name, right? What was your name? I'm sorry. Huh? Gorkam, right? Gorkam. Good. Gorkam, and you are Tahsin Chan, right? Gorkam, Tahsin Chan, Hamza, Marriage, Usman, Topdash, Hassan. What happened? Hussain and Ghazal. Okay, Abu and Hassan. Is this a rigid body kinetics problem?
Yes.
How? Good. What an answer. Sizes matter because if the size hadn't mattered, then we could have called it as a point mass kinetics. Because if, for example, this height is really, really big, then what will happen is that this object will just fall. It will tip. So the first thing that you will have to do, because sizes matter. Anyways, the first thing now in this problem, at least, that you have to do is, this is a kinetics problem. So let us make a free body diagram, and you have coefficient of friction that is given to me as mu k equal to 0.2, and 600 Newton is given to me. So you can put a 600 Newton here. Correct? The second thing is that the weight is given to me as 50 kilograms. That is 491, right? So you can just put a 491 here. correct? Then last but not least, you have normal. So where would I put the normal? Anyone? Where can I put the normal now? Anyone? So, well, the normal that you have to put, I am putting the normal here. So anyone who can tell us why did I put the normal here? Okay, I will answer this later then probably, if you are not sure.
It's like the center of gravity. The most weight is second root.
No, normal I'm intentionally putting here because this object can tip. That's why I put it at a random place.
I mean, the most pressure is applying to it. That's not.
No, what I am saying is that I put the normal here. Here. You are saying that I should put it here, right? At the center.
I'm saying, I'm just justifying you.
Exactly, right? Because if it has to tip, then the normal will be right at this point, the moment it is about to tip. You are right, actually. Good. And since we don't know, that's why I'm putting this normal at a random location from X. Now, where would I put the friction? It will be exactly where it will be in this direction, right? So it entirely depends on you. Where do you want to put it? As long as it's in the horizontal direction, none of us has any problem with your with the friction. So it will be mu k n c, correct? Now you can separately make a kinetics diagram, or usually what I do is I use a different color. So what will I do for the kinetics? I'm sorry, the kinetic diagram. There will be AG, right? Okay. Okay, do it then. Do the question. Is it clear? Is it clear why did I put NC at a random location? Yeah, because if the object is about to tip, then the NC will be here. When the object is definitely not tipping, the normal will be at the center. But I don't know whether it's about to tip or not. So I put this NC at a random location.
So it can be in the X.
Of course, it can be right at X equal to 0. It can be a few centimeters. It can be right at the edge. Okay, so the first thing I will do is in order to solve this problem, I will do summation of forces in the X direction is equal to MAG X, right? You can put a little X here. Then the next thing is plus P. Then you will have minus mu K NC is equal to MAG, right? Students who don't like the X can remove it. It's in X direction anyways. It's not flying in the Y anyways. So MAG or MAGX, whatever you like. The next is summation of forces in the Y direction. It is equal to MAGY. What is AGY? 0. So now I will have minus W plus NC is equal to 0. So NC comes out to be 491 Newton. Now give me X quickly. This is your task. I'm not doing it. 3 minutes, 4 minutes, I can wait. Just give me the value of NC. How would you do that? Yes, Hamza. How will you do the NC? How would you find it?
Moment.
Do it.
On France and in the acceleration of gyro X.
How much?
What did you find?
Yes. What is the answer?
It's I think I don't know, but I think it's minus 86.2.
10. 10 is in my notes.
10.
Yes. Did you get it? How? Okay, our students have already found it. Okay, so let me just do it for you. And you can tell me where did you make the mistake. So I will say, let's say clockwise moment positive. You can do anti-clockwise if you don't like this, is equal to Ig alpha, correct? So what is the value of alpha? What is the value of alpha? In a pure translation problem for this expression, 0, right? Now, I have explained this in the class for those of you who were coming in class. For those of you who are watching the recording, I'm not, I think I did mention it 1 or 2 times. Anyways, I have emphasized it enough that in a pure translation problem, if you are taking the summation of moment about any other point apart from the center of mass, then I have told you how that expression gets modified. In a pure translation, it becomes summation of moment about another point A. I have told you is equal to Ia alpha. And then it is equal to Ig alpha plus MAG into D. In a pure translation, which alpha goes to 0 and which alpha remains non-zero? I hope you watched the recording if you did not come to class. Well, this alpha will go to 0 in a pure translation problem, whereas this alpha doesn't go to 0. I have explained this multiple times now in this semester. Anyways, I don't need to use this about any point A. And again, this alpha is not 0 in this expression. Anyways, now I will finish the question by saying 600 into 0.3, correct? Which is equal to, okay, minus 491 multiplied by x plus, now I will have 0.2 multiplied by normal force, which is 491, multiplied by, what is the distance? 0.5 is equal to 0. So x becomes equal to 0.467 meter. Is this clear or not?
Hocam, where did you get 0.3 when you multiplied by
600, this 600 multiplied by 0.3, because this is 1 meter from the center point all the way up to the top, it is 0.5 meter.
Sorry, okay.
So my center is G, right? G. Yes, Mirj.
Why is the plus sign? It's going to
Clockwise?
clockwise.
I take clockwise as positive, but if you don't like it, take the clockwise as negative, then the whole symbols negative will become positive, positive will become negative. Your answer will still come out to be x equal to positive 0.467 meter. And for those of you who are wondering, why did you multiply 0.2 with 491? Well, 0.2 got multiplied with NC. This distance is 0.5. This is a clockwise moment, therefore positive. This is for, I apologize. Sorry. Then this distance is x. So I am doing the summation of moment about wait a second. Did I make a mistake? Let me pause the recording. Resume the recording. I apologize. This 491 is the NC. You see, it's so easy to get confused at times in life. This is NC. So I am doing the summation of moment about the center of mass. Sorry. Okay.
Yeah, because weight acts on the G point, so there's
Yeah.
no moment.
Huh? Yeah, exactly. So I'm doing the summation of moment about this point.
Yeah.
That's why this 491 is the NC. This NC. This 491 is not the weight. I'm doing the summation of moment about the center of mass. Okay. And that's why this distance 600 into 0.3 is also because I'm doing the summation of moment about the center of mass. By the way, for your own clarity, you can do one more thing. You can also do probably the summation of moment about this little point A, let's say. Do you want to do it? I'm not sure. We can make a mistake, but if you want, why don't you do a summation of moment about point A equal to? So let's say, let's call this point as A. Are you getting my point? So let's call this point as A. Okay. So if you do it, then what will you get? It is equal to MAG into D. And then you can repeat the process. Theoretically, you should get the same answer.
So
So
what is AG?
you have already found me.
10.
I think you already found it
So why did we find X there? Then? I don't understand what was the point of finding X.
because you want to see whether the object has tipped or not.
Hocam,
Now your X, I will answer first his question, then yours. The X is coming out to be 0.467. This means that the object has not tipped. If the X had come out to be equal to exactly 0.5 meter, this means that the object is ready to tip. And if the X had come out to be, I suppose, more than 0.5, this means the object has tipped. Yes.
hocam, shouldn't we multiply 600 with 0.8? Because height is 0.
No, I'm telling you that we are doing the summation of moment about G. So 0.8 and this is 1. This distance is 0.5. So that's why I multiplied this little distance, that is 0.3. Okay, you can do this summation of moment about A equal to MAGD. Why don't you do it yourself? So since you are not doing it, I will do it. Now you will have 600 into 0.8 clockwise. Okay, and why I am doing clockwise as positive, because MAG multiplied by D will give me a clockwise. Then 491 multiplied by X. By the way, our answer can still come. I don't know. I haven't done it. So this is the first time we are doing it. If we get the wrong answer, we can next time discuss. This is minus 491 into X. Then anything else? We have MAGX into D. So what is mass? 50 kilograms. What is AGX? Sure. 10 meter per second square kg. What is D, by the way? Anyone? What is D? 0.5, right? This one, right? This distance, this is AG, so MAG will be in that direction, 0.5. Okay, moment of truth. What is the X? I hope it comes out to be the same. Anyone? Again, the same? Sure. Okay. Our students are telling me they are getting the same answer. Is it clear? Confusing? For those of you who did not come to class, I emphasized it over and over again. Summation of moment about a point other than the center of mass. Look at the formula IA alpha. Is this alpha 0? Say yes or no. In a pure translation, is this alpha 0? No. Even in a pure translation, this alpha is still not 0. It's so confusing. But in the class, I have repeated it so many times. But IG alpha plus MEGD, this alpha is 0. Okay, let's repeat. In a pure translation problem, summation of moment about center of mass equal to IG alpha. Is this alpha 0? Yes. In a pure translation, this alpha is 0. In a pure translation, this alpha is not 0. Although when you expand it, then this alpha is 0. That's why when I used this expression of summation moment of A, I am still getting the right answer.
Hocam point A is just the point on the object, right? Doesn't matter where it is. It has to be apart from the central mass.
Huh.
Right?
Hmm.
So central mass alpha is always 0.
In a pure translation
In a pure
problem,
translation.
let's say the same thing. Let's say the complete thing. In a pure translation problem, summation of moment about center of mass is equal to IG alpha. The alpha is 0. In a pure translation, summation of moment about a point other than the center of mass in a pure translation, then when you do the IA alpha, that alpha is not 0, but when you expand it, then IG alpha plus MAGD, then the alpha with IG is 0. Okay, do the next problem yourself.
Hocam,
G. Yes.
hocam where the 10 meters per second came from? 10 meters per second square.
It came from,
Because
no, we found it. It came from here. Sure, you can use a calculator, take 30 seconds and double check. Okay, I think our students had double checked me. Okay, do this problem for me then. Quickly. This is your system. This is applied force is equal to 180 Newton. This is the center of mass. What if I give you a bonus quiz and I just give you a lot of bonus points because you came to the class, right? That would be fair to you because you are coming to the class. Do you want me to do it? Bonus points. Then if someone doesn't want to come to class, that's fine. I was really thinking about it. Anyways. The question says that starting from rest, so if this is your y-axis, this is your x-axis, and this is my x-axis. Bear with me, please. This is x-axis. The question says that starting from rest, you have to find starting from rest. Okay, I think it doesn't even matter whether you are starting from rest or not, because the question doesn't ask us anything else. But anyways, that is one thing. So I think I need you to give me the omega after 2 seconds. Okay. Now the question also says, let's say, find AG and alpha. So this is a solid cylinder or whatever. The question says that moment of inertia about its own center of mass is half mr square. Now the question also says that mass is equal to 15 kilograms and the R value is 0.5 meter. That is the radius. And this point is point A. It is pretty much at the horizontal, the point of contact. Okay. So it's more like a yo-yo problem. You remember we have this thread that is wound around this fellow. You are pulling it up and the whole yo-yo thing goes up. So the first thing that you have to say is, let's say summation of forces in the x direction is equal to m x double dot. And we have a gx is equal to x double dot, which is equal to 0, right? Similarly, the next equation is summation of forces in the y direction is equal to my double dot. Do it. I'm not going to do it for you. 5 minutes to take your time. Just do it for me. You can ask me a question if something is not. Okay, let's do it together then. So what are you trying to do? Of course, if the object is accelerating upward, first thing first, I will make a free body diagram. If you don't make a free body diagram, you cannot do anything. So in my free body diagram, this is the first thing. The tension is, I mean, the applied force, tension, whatever, if you want to call it. This is upward, T. Then I will also use a different color to put the kinetics diagram into it. That is my AGY. Okay. Anything else? I also have in my kinetics diagram the alpha. So if this object is going up, possibly it has alpha here like this. What about the weight? I will use the same blue color and I will put the weight. Agreed? So this will be my weight. What about AX? I will also put AX on my kinetics diagram. So let's say this is the AX, which I think we know it is 0. Now all you have to do is, if you don't like it, you can make this kinetics diagram separately, okay? But I just put it on the same diagram. So now I will have plus T minus W equal to MAGY. So AGY comes out to be T minus W over M. And how did you figure? The T is 180. The weight is 15 into 9.81 newtons divided by mass is 15 kilograms. Are you sure? 2.2, right? So AGY, one of the students has told me, is 2.2 meter per second square. Okay, give me the alpha quickly. Hamza, give me the alpha. Anyone who can tell me what is the alpha? Okay, so let me do it for you. The alpha will be summation of moment about the center of mass is equal to IG alpha. Agreed? Yes, no? Okay. Is this a pure translation problem? Is this a pure rotation problem?
No.
Is this a general motion problem? General motion, right? Because it's rotating and translating as well. The center of mass is translating and there is rotation as well. So I will write summation of moment about center of mass. So I will write if alpha is clockwise positive, then clockwise is my positive. So
Can I just ask a very quick question, please? Sorry for interrupting, but where is the translation? Translation motion?
oh,
It's just there's no-
yo-yo. No, it's a yo-yo kind of a thing. So thread, I just pull the thread like this, and the yo-yo thing is it's rotating and it's
Oh,
going
all
up.
as well.
Oh, for sure, AGY. How did I write the value of AGY as 2.19 if this circular thing is not flying into the air? So it's like thread wound around that wheel kind of a thing, yo-yo problem. I'm pulling it up, it's rotating and it's flying upward. So it will be plus T. Okay, alpha is clockwise positive. Why? Because Tashin Chan also agrees with me. We don't change the signs of the right hand side. So IG alpha is clockwise positive. So that I will keep, and then I will also keep the same notation on the left. So clockwise is positive looking at the right hand side because alpha is clockwise positive for me. I will have plus T into, what is the radius? 0.5. IG is given to me half provided into the question. 15 into 0.5 square alpha. Give me the value of alpha.
48.
Sure. 48. So I got a positive value, right? This means clockwise. Okay. Okay, just to be clear, there are students who are saying, but we don't like kinetics diagram on the same object. Why don't you make kinetics diagram separately? So for those students who don't like it, you can make, so let's say for those students, you can write separate pink color here, let's say, or whatever color. and you can make a separate kinetics diagram. This is your AGY, and this is your AGX, and this is your alpha. So you can put it in the same diagram, kinetics, or you can put it into a different diagram. And this is your, just to be clear, your point A. This, just to be clear, this is your point A. Acha, the next question is, Usman can also give me the acceleration of point A. So find the acceleration of point A. Anyone? How can I do it? It will be AA equal to, do you remember the formula?
IG alpha minus
No. It's a kinematics problem now. AA equal to AG plus alpha
this one.
cross position of G with respect to A. Okay,
Relative.
I apologize, mistake. A with respect to G. Look, everyone, you found the acceleration of point G. You found the alpha. I want you to give me the acceleration of this point. And what is the acceleration of that point A? It is the same acceleration as that point, because if someone is pulling it from here, then right at that point of contact, whatever A is, that is the same A with which someone is acceleration with which someone is pulling that thread all along, right? Got it? That point A, that's the same A. So you got the AG, you got the alpha. So AA equal to AG plus alpha cross R plus omega cross omega cross position of A with respect to G plus 2 omega cross velocity A with respect to G. Coriolis is not here, so it's a joke that we are even writing it here. AA with respect to G, small xyz, and I apologize, here there will be small xyz. Again,
Hocam, it is, I think, not omega, it's alpha. 2 alpha.
no, I'm 100% sure. It's 2 omega cross B. This is a Coriolis component. Anyways, it's a joke, 0. It's a joke, 0, because come on, those points are not going away or coming towards them. How can these components even enter? So you will be left with what is the value of AG? 2.19 in the upward direction. What is alpha? Clockwise. Clockwise means
Minus
negative K. What is A with respect to G?
0.5.
A with respect to G is negative. Please don't make mistake. Negative 0.5 I. Okay. Plus omega cross omega. Okay, what is the value of omega? What is the value of omega? Go back. Did I provide you the omega? What did I say here?
0.
0. Good. Very good. So don't get confused. So students told me 0. So 0. Give me the value of AA, please. To J. 26.2 J.
Yeah.
Very good. Hmm.
Hocam, but how can know whether this W is starting from the initial or not?
I had to tell you. I said in this problem, the mechanism is starting from rest. If I had told you that the initial omega or omega at this instant, for that matter, let's say at this instance that I'm talking about, omega is 1.5 clockwise, then put minus 1.5k into minus 1.5k into cross product RA with respect to G. Is it clear? At this instance, it was my responsibility to give you omega. By the way, the question said you have to find the omega after 2 seconds. You know the drill. Omega F equal to omega I plus alpha delta T, right? And what is the rule for this problem? The alpha has to be constant. So I suppose you can see that for this problem, the alpha is constant. Somebody has applied a constant force. If someone has applied a constant force, then alpha is hopefully constant. You can see from the answer.
Hocam, can I ask something?
Yes.
So you said in the vector form, alpha is minus 48 k, right?
Because alpha came out to be clockwise.
The clockwise, but we assumed clockwise to be positive previously.
Yeah.
How is that possible?
Yeah, but here we cannot just work like this. This is IJK. This is Cartesian coordinate system. Here we know anti-clockwise is k positive and clockwise is k negative. Here we cannot say I am assuming clockwise to be positive. You cannot afford to do that. Otherwise, everything will be wrong. Because I cross j is k, right? When you write on paper, I cross j is a k. So look, I cross j is a k. So anti-clockwise k has to be positive in Cartesian coordinate. Otherwise, I cross j will not be positive.
Because it was confusing in the moment equation.
No, in the moment equation, I said clockwise is positive. Why? Because if someone is pulling the thread upward, I can feel it. That force is applied. So it's clockwise alpha. Alpha will keep on. The angular acceleration has to be clockwise, right? Because someone pulling it like this, then its omega will keep on increasing. So alpha has to be clockwise. That was my intuitive feel. So that's why I said summation of moment about center of mass is equal to Ig alpha. And I said alpha is clockwise positive and then continue the problem. We have 4 minutes. Should I do one more problem? It will be very hard for me. This 50-minute thing adds to the problem. Acha, what I can do is, okay, someone has also already closed the books and papers. Do you want to at least see the problem? Okay, this is the problem. Can you see this? So do this problem in your own free time. Now understand the problem. We will do it next time. The problem says that this is this big fellow on which you can wire the rope. I mean coil the rope. So understand the problem. Someone is pulling it with 100 Newton, right? So what exactly will happen is that this fellow will roll upward, right? Are you getting my point? So the question says that you have to find the tension in the right wire, this one. You have to find the tension in this fellow. The question also says that you have to find the I think the acceleration of the center of mass. You also have to find the angular acceleration alpha. I think so. So AGY alpha and tension you have to find. And the question says that no slip condition is given to us. So I don't think we can do this question today. Next time when you come, I can do this question for you. Okay. Okay, everyone, have a good day, I suppose. Bye bye. See you. Bye bye.
Yes, yes, oh, yes.
See you. Bye bye.
Let it sound.
See you. Bye bye.